Let's go and build this amazing project. I always get the question where to start. And honestly, without having any sort of web service in place, you can't do anything at all. So that's why I always say, let's get started with a backend. As Delphi developers, that also comes more natural to us. So I prefer doing the web service first. It gets me into the vibe. And while I do that, of course, I need to know which information needs to be transferred to the client. That is something I have on paper, and I'm literally saying pen and paper. I'm not going to use any modeling tools for that. I'm very traditional when it comes to that. I use pencil and paper and model it all out. Obviously, it depends also on the interface that you want to build for yourself, what the client is supposed to get, which format and that kind of stuff. That's all very technical. In this case, it's going to be JSON because everything or almost everything in JavaScript nowadays is in JSON format. So that would be easy because that's what the default go-to is with XData. In this case, we're not going to build a typed web service interface most of the time. It's going to be flexible. So this is also very useful to learn how to build a flexible web service that is not based on data transfer objects that you have to build classes for first. This is all very dynamic based on the database result and the appearance of the chart. But without further ado, let's get started building the project. So first of all, I'm going to start new. I'm going to build other TMS XData, and I want to build a new TMS XData server, not service. Services are part of a server, so we start with a server. And this is already the point where I start building the project structure. So for whatever reason, TMS decided to name these Unit 1, Unit 2. Before, it was using dedicated names, but for whatever reason, they decided, hey, Unit 1 and 2, that's the way to go. I disagree. It makes it very, very difficult to find out what's what. So Unit 2 in this case is the graphical user interface, and Unit 1 is the actual server container component that houses the XData server itself and the dispatcher. We'll go into that in more detail in a bit. What we don't need here, we don't need a XData connection pool, and we also don't need an Aurelius connection because we're going to use FireDAC for everything, so we can remove that right away. And with regards to the endpoint, make sure that you have this endpoint reserved. The default here, TMS XData, is the one that the installer reserves. I'm going to use 80 in this case to make it simple, because then you can just write localhost and the web browser will assume that it's 80, right? That's why I use 80. In order to make sure that that is reserved, you go to the Start menu and look for the TMS HTTP config tool. It should be installed on your system. It's part of TMS Sparkle, and it must have HTTP plus :80 listed there. Otherwise, add it here for everyone, and you'll be ready to go. But you need this endpoint reservation in order for this to work. Also, I probably should have done this first, but let me just do this at this point, before we start the actual code. I go to the command line, go into my install directory. That's my TMS Smart Setup directory, TMS list. So these are the products I have installed. I have installed from the business library, the Business BCL, Business Aurelius, Business Sparkle, and Business XData. In order to get there, you simply type TMS install TMS biz XData, because XData depends on all of these. So that's the only thing you need in order to install this if you use TMS Smart Setup. I just wanted to put this out there, how advantageous it is to introduce TMS Smart Setup. Look for videos on this channel into your production, because it makes installing and updating TMS software so easy. Before I started recording this tutorial, I actually ran TMS self-update in order to update the install process, and then I ran TMS update to make sure that I had the most recent version of XData, Sparkle, BCL, and Aurelius on there. Okay, with that in mind, of course, it's not supported by TMS Smart Setup yet. I know that TMS is working on that. TMS Web Core has to be installed through traditional installers because it's not supported by TMS Smart Setup yet. That's, of course, also a requisite in order to write web applications with TMS Web Core. The vanilla JavaScript version, however, just requires you to install Visual Studio Code, which is free, and then everything that we use is free. So if you just want to have a look at TMS XData, you have the business platform from TMS, and the web application then with vanilla JavaScript does not require TMS Web Core at first, and that's something you can look in without installing TMS Web Core. However, I add this all the time. TMS Web Core also has a trial version available, so there's really no reason not to try it out. Again, Unit 1, Unit 2, really stupid naming scheme. So we do file save all, and then I go to my disk F, and I'm calling this XData stock service.live. You see I already have the finished version right there. You're going to recreate this while I'm doing this with you. And Unit 1, this is why I don't like it. Now I have to think about what is Unit 1 in this case. Is it this one or this one? But Unit 1 we knew is the userver container. And I'm not going to save it right away into the XData service live directory. Instead, I'm going to create directories for the different projects we're going to have. So we're going to have the service. We're going to have the web core. And we're going to have the vanilla JS version. And service I should probably rename in server. Okay, so, or backend, whatever you prefer. Server. And then there I'm going to create the source directory. Source. This. In the source directory, I'm going to put the server container. Like this. And then Unit 2 is the uform main. That's the main form that gets shown when the server is run in development mode. So save. And now the last but not least part is the project file. So again, I'm going up, and I'm going to create the server in the server directory. And this is really how you like it, if you make it part of the source directory or if you make it part of the directory above the source directory. That's what I'm going to do. I'm going to name this stock service.http to make sure that this provides the HTTP services for my web applications. So I'm going one directory up. So the source directory is the next one, and then save. And this is now my application. For whatever reason, this still looks like this. So you close everything down if the project manager does not update, and you go File, Open Project, then make sure that you go into the correct directory, Live, Server, and then here, this is another thing that Delphi tries to screw with us sometimes. It selects group projects, so I want to select all of them, and then here's my Delphi project, and now it updates correctly that I have my main form and my server container right here. Why that is the case, all of a sudden, I don't know. It makes things a little bit more complicated, and the naming scheme from TMS does not help here at all. The reasoning is that Embarcadero also creates Unit 1, Unit 2. I just think it is better to name these things for what they are to avoid any confusion. Of course, at this point, if we try to run this or compile this, it doesn't work anymore because the visit generated with Unit 1. So here in this case, we have to add userver container. And then it will work again. However, and this is the first thing we're going to fix, right now we are using a global variable for the server container, and I really do not like that. So what we're going to do, we're going to replace this with a singleton pattern. And that means that I don't have to use a global variable. Instead, I have a singleton pattern and can then add my methods to this. So that's the architecture change that will make this loosely coupled to the server container as well, because right now we have here things like server container, and we use components from the dispatcher over there. I don't like it that we use components on the other form from the user interface. We're going to fix that also. We already fixed the base URL to port 80. The next thing we're going to do, we want Swagger support. You'll see that what it does as soon as we actually work with the XData server. We add the server Swagger UI options. We want to display the operation ID, and we want it to be enabled. Perfect. This will generate additional information. It will actually generate a web page for us that allows us not only to create a documentation for the server that we create. No, it will also allow us to try the server without having a web application, which makes it the perfect solution for us because we don't have a web application yet. Let me explain the components that we have on the server container first. We have the XData server. I'm going to rename that to server. That is the actual server module, server component that manages everything that comes in and goes out of the server. And what is that going to be, or how is that negotiated? Well, using an HTTP sys dispatcher. And this dispatcher is nothing. If you have seen the deployment series from me, or if you're just watching the deployment series, this is reserving, or is what is communicating with the HTTP sys stack of Microsoft Windows. That means this is what allows us to communicate through HTTP, and this is part of the Sparkle framework. But the only thing that is interesting for us here is that's the dispatcher. And whenever the dispatcher is true, the server is listening and is available for requests. So why this by default is active, I don't know. I set this to false. So when we start our application, this is not active. So let's see if it runs. We still have a mistake in here. Yes, of course. Now we have the renaming to do. Let me do that real quick. Dispatcher. Still, we will get rid of these calls that we basically grab these components from the main form. I'm going to implement that differently. So now it compiles. We can start it. And the only thing we get now is server is stopped. And if we start it, cannot create a file. That file already exists. Why is that coming from? Well, look here. There is a server already running here. Which one is it? It is the one that I used to show you the example. So if that message appears, you either don't have the endpoint reserved or you have another server running on that port. So let's start it again. Start, we get localhost 80. I go to my web browser and I type localhost, and that's it. And here you should get now value is empty. That's the very, very interesting result from the XData server. That's the result that you get if an XData server is running that has nothing in it. If you type Swagger UI, I don't think that you will get anything here. No operations defined, because we just have the frame. We have the server components, but we don't have anything inside of our XData server that would return any information or anything. This is just the empty shell. If you have this working, you're actually at the point where you now add either just normal functions that return values, but if you want to return database-specific things, it doesn't mean that you only can return full tables or specific queries. You can mix it. You can have web service functionality that is not dependent on the database, but at this point, we need to also add the connectivity to the database. But let's first fix the user interface and make the server container a little bit more object-oriented. What I will do is I will draw this open. I will add a strict private section, and I will add a private section right here. And we will have a public section. And what we need is we need a procedure to start the server, a procedure to stop the server, and we also need a property if the server is active. And if Delphi lets me, we also need a base URL, which is a string, a property. And these should be read only. And what I want to say is I want to get active. and get the base URL. And this is what I mean. I don't want to grab something from the components directly from the outside. I can now say server container.base URL without actually knowing which component that is dropped on the form supplies that to me. That's the reasoning why I'm doing this. So code completion, hopefully it will work some magic. It does. So we have get active, get base URL, and these we can get rid of. They're no longer needed. And then if we keep going, get active, what is the active state? Told you before, a couple of minutes ago, the dispatcher has an active property, and that's how we know if the server is active or not. And then the base URL is on the server, the base URL property. So now I can use the server container.base URL or server container.active in order to query if the server is active and what the base URL is. And then with regard to start, very simple, we can implement that simply by flipping the active flag. So I can say dispatcher active is true if I want to start the server. And if I want to stop the server, I simply say dispatcher active is false. That's all we need to do. Get failed because it's still, this is the thing I always forget. The server is already running, so I have to stop it first if I want to recompile. There we go. Linking compiles fine. The next thing is I want to make this a singleton. So I'm going to remove the server container global variable like so. And instead I'm going to introduce a class variable f instance of type T server container. And I'm going to create a class destructor. And of course, I need a class function to create the instance, or get the instance, I should say. It might be created, it might not be. So class function instance T server container. If you see it how it works, you'll realize how nice it is. I'm not going to call it instance, I'm going to call it shared. And then autocomplete, Control-Shift-C. For destroyed, I'm going to say finstance.free. What is finstance? That's the instance of the class right here. I defined that. And that's on the class level. That's not on the instance level. That's the thing where it gets a little bit complicated. So we free the server container if the instance is assigned. And with regards to the shared function, I'm going to say if not assigned. So if the instant has not been initialized, then begin finstance is tserver container.create nil. And we're going to result finstance, we are going to return the instance. So that means we are only going to do this once. If finstance does not exist, we are going to create it. And if it already exists, we're just going to return it. That's the singleton pattern. There will only be one server container in our application. If you have a problem thinking of singleton and you're good with movies, think of server container, think of server container or the singleton pattern more or less as the Highlander pattern, okay? If you're better with movies, because there can only be one, right? So, and this construct here makes sure that you can only access one instance of it. Formally, I would have to override the create constructor and make it private. I'm not going to do anything like this. So you could still create server containers using the create constructor. Of course, I'm not going to prevent you from doing that. But whenever we access the server container, we're going to use shared instead now. Let me show how that works. So now if we compile this server container dispatcher start, which is linked to the start button and to the stop button right here, doesn't work anymore. Instead, we have the reference to the server container that's still there. So we can now say, instead of that, we can say tserver container, and we have a class method shared, and that returns the server container. And on that server container, which is an instance, we can now say start, right? So instead of accessing the component, because we don't know what components are on that form, so to speak, we call, basically give me an instance and then call the start method, like so. And then we update the user interface, and then here the same thing. Just instead of start, we're going to call stop. And then here, when the user interface gets updated, button start enabled is, okay, and again, tserver container shared, and we have the active property. So start should be enabled if it's not active. And then this is the reverse of that. And here again, we can use the same clause here. If it is active, then do this. And then here, the base URL, same thing. We no longer have to use the server component. Instead, we can say shared and then base URL, which is also a property. Done. So now we remove the dependency to the global variable and also the dependency to know which components. You saw how awkward that is. If we rename this component here, this is still going to work. So you have no longer a dependency between the component names and your user interface here. Okay, that's very important for bigger projects to make it more robust and easier to maintain. So go in here. We get a server container, yes, because the application by default creates the server container. We have to remove this. We can either remove this in the form or in the code, I should say, or we can go to project options. And then here in the application forms, we can move that over. It's the same as removing it here from the source code like this. Okay, save. And now we can start it. Still works the same way. We also removed another possible bug that might occur, because if you use this, it might be that the main form gets created before the server container, and then you have a problem because then your main form has all these global variable server container in there and it's not been created yet. So you remove that dependency nicely if you use this Singleton approach. So here, start. And then we go to localhost again, and then Swagger UI. I mean, we didn't change anything, so it's working again. Okay, I just wanted to show you with the changes to the Singleton pattern, we didn't change that much. So that's all we do inside of the server container. The only thing I'm going to do now is on the form, I'm going to change the fonts a little bit because it's too small. I don't like it. I'm going to say font size is 12. Not only for the button, I want to do that for the whole form. Like so, form, and then size 12. I also don't want to use Tahoma. I want to use the standard Segue UI, the correct Windows font. Perfect. And then here on this one, I want to use something that is more appropriate for logs. I'm going to use something like Consoles. Monotype 14, bigger. Then if we make this bigger, I want to have the start and stop like this. And I also want the buttons to be a little bit bigger so we can hit them easier like this. Okay, stop, start. And the start here can stay as it is. And here we have to change the anchor from left to right. And the user interface is a little bit more clear too. And we could also add something like log or whatever to the main form. I'm not going to do any of that. You can basically extend it as much as you want. And then here for the capture, I'm going to say XData charting example server. Perfect. Okay, and I'm going to change the style. I'm going over to the border style. Where is it? Border style here. I'm going to change that to sizable tool window. Perfect. Excellent. I said in the beginning we want to access a SQLite database, and the SQLite database is supplied in the source code. So if we look at the project that we have built so far, we have the live project, we have the server, and then we have the source. And in the source directory, we have our forms and all that stuff. And here's the project directory is right here. And in that project directory, you get this ugly Win32 debug and all that kind of stuff. So instead, what I'm going to do, I want to have a binary directory here. in this. So we have source, and then as a different directory, we have binary. So if we look at the source code that you have, we have the server, we have the bin directory, and there is the database, and there is the executable. So I'm taking this database because obviously I need the database too. Go into my live example server, create the binary directory. And in order to get the server created in this binary directory, I go to Project, Options, and then Delphi Compiler. I go to all configurations for everything. I want to make sure whatever I select here, because we're not going to have a release configuration or debug configuration or anything different. I'm simply going to say I'm going to go basically to bin. It's relative to where the project files are. Okay, so here bin, Control F9, linking, and if I now look, I have my executable where the database is. Okay, that makes it easier to access the database in the bin directory. Okay, so the database, how do we access the database? Well, we need an FD connection, right? And then we need an FD query. And after the FD query, please drop these components on the form because that gives you the users clause that you need, okay? FD query, and then we need the cursor, the what is it called? It's like the GUI X wait cursor, this kind of thing. And you need the SQLite components, the SQLite driver link like this. Press Control Save. What that does is it updates your users clause with all these nice FireDAC components, right? And we connect using an FD connection, and the connection uses a query. The query then can execute SQL commands to the SQLite database. Sadly, this is a multi-threading environment because multiple users access your web service, and especially multiple users can access at the same time. And for that, you need to program FireDAC in a multi-threading way. The FireDAC documentation has a great article about it. You look for FireDAC multi-threading, and the key component that you need is, in this case, is called manager. It's called or FD manager, I should type. FD manager right here. That's the key component. You need that on your form, okay? And you need to set it to active true, because that component makes sure that your FireDAC application supports multi-threading. That's the key ingredient, okay? Without this component, it's not going to work. And we're going to name it manager. We're going to set its active property to false, and what I'm going to do to make sure that active is flipped to true at runtime and nobody messes up in the configuration in the object inspector, here I'm going to say manager active is true. I'm going to write it in code, so nothing can go wrong. Even if somebody fiddles with this component here, the important thing is this thing has to be true as soon as the data module is created that houses everything. And then we sadly can't put the connection or the query on this server container because that would imply we're using the same connection and the same query for each request. However, in a multi-threading environment, we need to have one connection for each incoming request. And that's what we're going to separate into a different piece of code so that delivers to us a connection and a query whenever we need it, okay? And we're going to wrap that in a database manager. That's what I called it. So let's create this database manager that I just talked about. So we go here, right click, and we do add new data module. And the reason why we need data module is the manager that I just mentioned in the server container goes on it. So we go here, X, and then we paste it in here. Poof, that's it. That's all we need. We only need this manager component. And then we can say file save as, and we save it in the source directory as you database manager save. So here, empty unit, it already has some of the FireDAC units that we might need. We need more though. So what I'm going to do is I'm going to copy paste the definition that I have in the source code over. You can do the same. And how I got this list is very easy. I went to the server container and copy pasted from starting from FireDAC until the end, and then added the system classes, system sysutils unit to the list. We rename the data module, of course. We rename it to database manager. And then, of course, we need to remove once again this wonderful thing here. Make sure I have this disabled if you go to your project file, if I can find it in the GUI. Where is it here? View source. That it is not being created, only the main form is being created. That's very important because we're once again going to use the Singleton pattern. So strict private, and then we have here class variable f instance t database manager. And inside of the database manager, of course, we have the public method, which is class function shared. And that is of t database manager. And then the destructor, class destructor, not destructor, right? Destroy. We free the instance. So f instance dot free. Perfect. And in shared, we do the same thing as before. If not assigned, f instance. If it's not there, we need to create it. So we say f instance equals, get out of my way, t database manager dot create nil, because we created it and free it ourselves, so no owner. And then we do result is f instance. Perfect. So that's the Singleton functionality. And now we need to implement the key functionality that we need for this database manager. We need a new connection each time. We need a query, and we need the ability to free both things from memory, whereas I have to be a little bit more detailed. So whenever we ask the web service to deliver a query from or for the database, or deliver a connection, I should say, it is being taken from a pool. And in order to return something to the pool, we have to free the connection. That's how FireDAC implements it. Think of this pool like a pool of connections that stay open the whole time. Because if you connect to a database with SQLite, this is not the case, most likely. But if you connect to a database and it is the first time, it takes longer. And that would be very, very time consuming if each time you ask your web service for another thing, it needs to connect to the database again. So FireDAC keeps a pool, an amount of connections open, and always serves from this pool to the different web service methods. But in order for that to work, you need to return the FD connection instance to the pool, which you get by calling the free method on the connection. So that is what we need to do. So we first of all need to get a connection, and that is a TFD connection. And then we need to get a query, TFD query. And we want to only create a query based on the connection. So we could move this to private because we only want to call get query from the outside. And we want to release the query and call it a query, TFD query, to return the connection to the pool. Okay, so how do we get the connection? That's the first thing. If you define connections yourself in FireDAC, let's do this, FD connection, and we have the connection object here. We also have the connection definition name. That is something you can define definitions using the FireDAC Explorer. These are so-called persistent definitions name that have the connection parameters right here. You can also just double click on the connection, select SQLite, and then set the parameters. However, for pooling, it only works if you use connection definition parameters. And there is not only the persistent one that you have to modify your INI file. No, you can also use one that is in memory. And that's what we're going to do. When the application starts, we're going to create one and one only. And that's why this database manager is so suitable for it, because the database manager has the manager component on it, and that takes care of all the definition names. It reads it in. You can see that here, that they load the INI file if there is one, but it also takes care of the ones that are in memory. And that way we can reserve the connection name with our specific connection, because the pool can only work if each connection has the same parameters. So let's go into the code again for get connection. And first of all, we need the constant for our connection definition name. So Control-Shift-C, and we need a constant. So here we say condef, I name it, and it's like SQLite pool. You can name it whatever you want. It's just important that this name is only used once. And then get connection. How do we get a connection? Well, we ask the manager, is the connection definition with this name, condef, is this known? If not, then begin, we want to create it, right? So in order to create a definition, we need a string list. So we say lparams is tstring list. And this could probably be loaded from a configuration file, for example. If you don't want to hard code it here in code, you could say try finally, and then lparams.free. And then here we say lparams add database is stock.db, and that's the database in the binary directory. And then the other thing we need to add is pooled equals true. That's it. And then we need to add the connection name. So we call manager.add connection definition, which name, condef, that's the name of the definition. Second parameter is the driver. And third parameter is these list of parameters. And the fourth, if you want to make it persistent or not. So it's going to be false. So we say here, then here, SQLite, lparams, false, not persistent, and that's it. So this way we have added the connection. And then in order to supply the user, or the developer, I should say, with a connection, we say result is tfd connection.create. We don't have an owner of that connection. So result.connection def name is cn is condef. So that way we set the connection definition name to the name of the connection that we just created up here. And we only created once because this will return true as soon as it's in memory and has been created once. And this way we can supply any connection. And for example, if there already is a connection in the pool that is available, FireDAC will return that connection from the pool. But if, for example, 5 connections have been in the pool and 5 have been used, and another user wants to access your web service at the same time, a 6th connection is getting retrieved. Look up in the FireDAC documentation. You can configure how big the pool is, how long the actual connections stay connected and are basically recycled. All this is configurable using FireDAC. Going to get query is where we get a query for that connection. So we say var l connection is, surprise, surprise, self.getConnection. And then result is tfd query, create. We create a connection and we tie the query to the connection. So that means if we free the connection, the query is freed as well. That's the trick here. And then we do result.connection is lConnection. Perfect. So when it comes to the release query, and I said like we have to release the connection, and if we release the connection, if we free the connection, because it owns the query is freed as well. So the only thing we need to do here, if we pass in the query, a query dot connection dot free, that's it. That's all we need to do, and that will automatically free a query as well. So that's the database manager. What does it say here? Undeclared identifier manager. Oh, of course, this is in the server container. We moved that over into the database manager. And there, I think, the database manager, let's see, double click yeah, we have to say manager active equals true. And then just make sure that we set it to false, that it's not active while the IDE is working or anything like that. I just want it at a runtime. Okay, the server container data module create can go away. We should get an error now. Correct. And now, yes, we want to remove the reference from the object inspector as well. And there we go. Now we have our database manager at work, and we can access the database. The database itself, I haven't shown you the structure yet, is very, very simple. So here's the content of the stocks database. It's just one table. So it's stockdb, and there's just one table named stocks, and that has the properties date for the date when this stock value was retrieved. And it's not only one, it's like at open, high, low, and close. And I also have volume, unadjusted volume, and all that kind of stuff. It's not a normalized table. So here on the right, you have the symbol. So this has literally been imported from a JSON document that I retrieved from another web service. Just to keep it simple, you have it all nicely wrapped inside of a database. Of course, you could also do your XData web service, that web service gets the information from another web service from the internet that has the current stock values. I just didn't want to complicate things so much. So I simply extracted the values starting at June 18 or ending at June 18, 2024. And it goes down, I don't know how far. See, this is all Microsoft and we're just in 2022. It goes down to 2019, all the stock values from Microsoft, Apple, and NVIDIA, that's in the database. And what we want to do first is we want to be able to determine all the years that are inside of the database, and we also want to determine what symbols are in there. So if we, for example, run a query select distinct symbol from stocks, we should get Microsoft, Apple, and NVIDIA. That's one of the queries we want to run. And the second one is we want to be able to determine the years that are inside of the database. We want to know, is it to 2024, 2020, uniquely. So we have the list for our graphical user interface, which years are available and which symbols are available. And we can do that very, very simple by writing the following query, which might not come natural to us because the problem is that SQLite doesn't have real date and doesn't have a date type. So everything is a string. And then we must basically the string, we must convert that to a year. And nowadays it's very, very simple to get these kind of things. You simply ask Copilot or you ask ChatGPT. So we say select, and then it's string to string format time, and then we can say here the year for the field date from stocks, and we correct the parentheses. There we go. This is all the years from date, and now we add distinct. And then we have 2024, 2023 in the right order. We can also add order by, and this is where it gets a little bit tricky. I say here year, and then order by year. There we go. Now we have it ascending, and I want it descending. Certainly. Good. We can't assume that the rows in the table are in a certain way, so I always add the order by. So these are the two statements that we want to add to our web service first, so that our web application is able to retrieve these. So that's what we're going to do in the next part. Let's take a break.